Hey guys, today we're going to talk about polar coordinates. So first off, what are polar coordinates? Well, let's take a step back and look at, the rectangular coordinates. X, Y are Cartesian coordinates. We have the XY plane, da da da. I got my x-axis here, y-axis here. Well, polar coordinates, instead of having XY, we now have R and theta, where we have a radius r and a particular angle of theta. Okay, so my radius, is from here to here, and then say this is my theta. And there's different variations of this, but going back to the trigonometry of it, well, it also relates to the unit circle, because if we think about the unit circle, we have x here, we have y here, da da da. So for instance, what is cosine? X over r, right? So cosine theta is equal to x over r, right? Just like sine theta is y over r. So, well, now what we want to look at is, let's solve for x here, all right? So if I solve for x here, I multiply r over x is equal to r cosine theta. And I solve for y here, well, same thing. It's multiply r to this side. Y equals r sine theta. So another important aspect is we look at the triangle here. We know this is a right triangle. Well, what does r equal? Well, Pythagorean theorem. We have this side squared plus this side squared equals our hypotenuse squared. So it's x squared plus y squared equals r squared. Take the square root of both sides. R equals the square root of x squared plus y squared. Now notice, plus or minus, but radius is always positive. It's distance, right? So the important points of this are right here, that x is r cosine theta, y is r sine theta, and r is equal to the square root of x squared plus y squared. So let's look into plotting points, right, in polar coordinates. So for example, if I have the point 135 degrees. So my r is 2, my radius, and my theta is 135 degrees. So if I draw it out, so imagine this is the center of a circle. It's a distance of 1, let's say. This is 2. So this is my radius. And I want to draw it 100. I want to take it and draw it to I want to take it and, okay, I had to have it 135 degrees. So I go like this. Well, this is 90. And 135 be right about here somewhere. All right. So then this would be my whole angle, 135 degrees, with r being 2. Now, another scenario that you'll come across is, say, for example, I have something like, the point -3 pi over 2. Now, I know I said before, yes, r is always positive, but with polar coordinates, you can actually have your radius negative, which I know sounds kind of strange, but it's just how it works. So for example, r is -3 pi over 2. Well, first off, I have a positive angle, which means I'm going to wind up going counterclockwise, right? Generally, yeah, that's true. However, what happens here, since r is negative, I start from the negative part of the x-axis. So I'm going to start here at -3, And then again, since it's a positive angle, it goes counterclockwise like this, right? So since it's 3 pi over 2, well, this is pi over 2, this is pi, and then bam, 3 pi over 2. So that is this point right here, -3, 3 pi over 2. So let's go into something a little bit further now, right? So for instance, say now, you know, I want to convert from polar coordinates to Cartesian coordinates. So in other words, I'm going to go from, you know, polar coordinates are theta to Cartesian or rectangular coordinates x, y, right? So for example, suppose I have in polar coordinates 2, 3 pi over 2. So, okay, well, my r is equal to 2 here, and my theta is 3 pi over 2. Well, going back to before, right, x equals r cosine theta, and y equals r sine theta. So I know my r, and I know my theta. Well, this is very straightforward. X is going to equal 2 cosine of 3 pi over 2, which equals what? Well, 2 cosine of 3 pi over 2 is 0, so 2 times 0 equals 0. So therefore, x equals 0. Similarly, what about for y? Well, it's going to be y equals 2 sine of 3 pi over 2. Well, 2 times, well, what's sine of 3 pi over 2? Sine of 3 pi over 2 is -1. So 2 times -1 is -2, so y equals -2. So therefore, the point 2, 3 pi over 2 in polar coordinates to Cartesian or rectangular coordinates is just going to wind up being 0, -2. And another important aspect is sometimes you wind up having, you know, something where, okay, now, yeah, those are, you know, converting points, but now what if I have an equation in the xy plane, something like x plus y equals, I don't know, let's say 8. Well, again, right, I know x is r cosine theta, and y is r sine theta. So I want to take this equation here, x plus y equals 8, convert it from rectangular or Cartesian coordinates, excuse me, to polar coordinates. Okay, well, what is x here? R cosine theta plus r sine theta equals 8. So I want to have it so that r is a function of theta. So that means I have to have, you know, r in terms of theta, so I have to solve for r. So here, what do? Well, use some algebra, factor out an r, you get r equals cosine theta plus sine theta equals 8. I divide both sides by cosine theta plus sine theta, and that's going to give me r equals 8 over cosine theta plus sine theta. So that is the conversion, that r equals 8 over cosine theta plus sine theta. And that will do it for today. I hope this video helps, and have a great day.